Yes, we are good to go.
Rituja, you can start.
Okay. Uh, so, good morning, everybody. I am Rituja Zadav, and I, on behalf of Young Professionals team of IEEE Pune section, extend a warm welcome to all of you for our session, Career in Data Science. We are delighted to have you all here, and we hope the session will be insightful and enriching. I would now like to introduce our speaker for today, Dr. Neha Sharma. Dr. Neha Sharma is a data science crusader who advocates its application for achieving sustainable goals and solving societal, governmental, and business problems. She has more than 24 years of experience and is presently working with Tata Consultancy Services and is a founder secretary for Society for Data Science. She is a senior IEEE member, ACM distinguished speaker, and was secretary of IEEE Pune section for the year 2021 and 2022. She is the recipient of IEEE Region 10 Outstanding Volunteer Award. Her achievements and involvement in IEEE activities speak volumes about her consistent dedication to IEEE. She is also the recipient of Best PhD Thesis Award and Best Paper Presenter at the International Conference Award at national level. Recently, she has received the Golden Book Awards 2023 for the book titled Towards Net Zero Targets, Usage of Data Science for Long-Term Sustainability Pathway. A very warm welcome, ma'am. I now request you to take over the session.
Thank you, Rituja. First of all, let me thank each one of you who have planned this session and invited me to talk to the community in IEEE Pune section and maybe beyond. And in fact, this topic is very close to my heart. In fact, synonymous to my existence. In fact, So we will be talking about couple of things. I think I can skip this. Rituja has already shared. So today's objective would be we'll start with seeing what is data science, why it is needed, what are the fundamental concepts. Maybe briefly we will touch, we'll not dive in too much. Some ecosystem of data science, sources of data, why it is so exciting, and then careers in data science. And of course, I would like to share my journey. So why, when the topic is career in data science, why I have thought to include all these topics above that, because I feel like unless until you understand, see, career carves out of the concept, when you look at the positions which you can hold, it is directly related to the concept of data science and the elements which are there in that, so to appreciate what is the position, to understand what the position is and what you are expected to do when you are in that position, it is very essential that we know the fundamentals, right? So very briefly, I'll touch upon a couple of concepts. I'm sure, I mean, you can just sit comfortably. There's no stress. Just listen to it as a story. I'm sure you'll enjoy it. So to start with the fundamental question, when you start a class, the first thing is what is data science, and you can clearly make out that it's a combination of two words, data and science, and when we look at the dictionary meaning of science, it says that it is the structure and behavior of anything. When you study the structure and behavior of anything, that is called science. For example, if you study the structure and behavior of, say, earth object, it becomes earth science. When you study the structure and behavior of space object, it becomes space science. Likewise, when you study the structure and behavior of human behavior, then it becomes behavioral science, so on and so forth. Similarly, when you study the structure and behavior of data, it becomes data science, right? It is as simple as that. So entire stream, entire vertical, entire specialization is about looking at data in very critical way, trying to understand the structure and behavior of it, trying to find out what data has in store for all of us so that we can do our job in a better way, we can have better insights, we can do things in a more intelligent way, right? Something which we are not aware of, data might tell you. People say that, okay, you just torture the data and it will tell you the story. So this faculty, this specialization is about treating the data in a way that it tells you the story, right? I'll start by sharing a survey. The survey was done in the year 2006, and the survey was all about finding out the top global 10 companies of the world, right? Now, in the list of the result of survey had five energy companies and one IT company. And in 2001, that one IT company, which was there in the world's top 10 leading company, only one, mind you, only one, that was Microsoft, right? Now, the same survey was done in the year 2016. That means after a decade's time, which is nothing, with just a blink of eye, you can just see that, okay, you are already there. The same survey was done after a decade, after 10 years. Now, the result was slightly different. Not slightly different, it was there was a major change in the survey result, and now there were around five IT companies and only one energy company. So the question is, what happened in just 10 years? I mean, 10 years are nothing, when you consider business trajectory. Yeah. So what happened in this 10 years? So the companies who could make it, the IT companies who could make it to the top level at global scenario, so those companies basically realized what is the power of data. First thing, they realized that they have the ammunition with them in the form of data. Then they realized, okay, data is very powerful and we can play with it, we can do some experiment with it, we can do some innovation with it, and it has got a power to put it in the top level at the world forum, right? In 2006 only, I mean, I'm still in 2006, long back, because if I have to tell you this story, if I want you to appreciate the story and the stream of data science, I have to tell you a couple of stories. So 2006, there was one interview which was given by ex Google CEO Eric Schmidt. He said in his interview that right from the beginning of the time when we started collecting the data till 2005, we had around 130 exabytes of data, right? And now in 2005, 2006, he gave the interview. He said, now we are creating this amount of data every 2 days. Now, can you imagine how much data he's talking about? How much is this 130 exabytes of data, right? So just to give you the perspective, I mean, we started with kilobyte, then megabyte, and then gigabyte, and so on and so forth. We are introducing the bytes in every thousand, with this. But do you even know how much data you mean when you say 130 exabytes of data, right? And now it is not even 130 exabytes, it's too much. So how much space will this alphabet one take in the space, in the memory? 1 byte, we all know, right? Now if you imagine that you have 100 characters like this, which can be easily accommodated in 2 pages, 500 characters on one page. So 2 pages with 500 characters each, it can be easily accommodated in 1 KB of space, right? Now, if you consider a book, which has got around 2000 pages with 500 characters on each page, this can be easily accommodated in 1 megabyte. So we have reached till 1 megabyte. Now, human genomics can be stored if you just take the storage by 1000, another 1000, if you add the storage, another 1000 KB to that storage, so 1 gigabyte. So 1 gigabyte is enough to store your human genomics, right? You increase it by another 1000 times. Now you will say that, okay, human beings are not just about the genetic structure, they're about the say the activities they do, the awards they achieve, the thought process they carry. So human beings are all about everything over and above the genetic structure, right? So if you suppose you take a camera and start recording each and every moment of a human being, start documenting every single activity of or event of a human being. So this data which you will create, assuming that every person, a general person, lives for around 80 years, so you can store all of this in 1 terabyte, right? Now assume this is Amazon forest. Now assume that this forest, which has got 1.4 billion acre of land full of trees, if you chop the trees and spread it on, of course, I'm not trying to propagate cutting of trees by any means, but just imagine if you spread it, the chops of trees on silicon paper, the amount of space it will take is 1 petabyte. I'm just trying to show you the volume. The volume we are talking about, we easily say 1 exabyte, right? How much it means? You increase this volume by another 1,000 times. That is 1 exabyte, right? Now we are talking about 130 exabytes. Let's look at rewind and let's look at the same journey once again. 2005, 130 exabytes. 2010, 1200 exabytes. 2015, 7,900 exabytes. 2020, we have already surpassed this. 40,900 exabytes, or you can say it approximately 41 zettabytes. So when you use these terms, I want you to understand how much volume of data you are talking about, right? Let me plot this. I have done nothing great. I have just plotted this. And people say that by 2025, it will be 140 zettabytes. Look at this graph, which I've just plotted from the previous screen, the data which I presented in previous screen. I've just plotted it. And I have also plotted the prediction of 140 zettabytes by 2025. Look at the volume and the growth of the data. It's exponential in nature. Now, out of this volume of data which you have, the small portion of data in the bottom of your screen can be seen, observed, processed, and handled by data scientists. The people whom you say can treat the data in the best manner, best possible way, right? So only this small portion of the data can be seen, processed, observed, and treated by data scientists. A little more data, you can employ machine to do what you want and handle the data. What are you going to do with this remaining volume of data? How are you going to look into that data? So when we say it's impossible for human beings to see and appreciate and find out sense out of the data which we are creating, is this volume of data, right? And that is where machine learning comes into picture, where we train machine to learn on its own, right? Now to basically, if you do not believe me, you have to believe Tim Berners-Lee, who is the inventor of World Wide Web, and he says the data is the precious thing and will last longer than the system themselves. So technologies will come and go, systems will come and evolve further, get better day by day. Only thing which will not change, which will stay with you, is the data. And Mr. Vinod Khosla, who is co-founder of Sun Microsystem, he said that in next 10 years, data science and software will do more medicine than all of the biological sciences put together. That means, whichever business has got data, the possibility of having data scientist and data science as a specialization there is very much there. So you can't say that, okay, only this type of work can be done by data scientist and data science stream. Now there's no business which is without data. Every business is a data business. So there's a possibility of you as a data science enthusiast of being there in every business. So that is the width and the spread of the data, right? Now to appreciate it further, you have to look at the evolution, right? Evolution of what? Not data, evolution of the earth. So universe was created. You can keep on speculating, keep on thinking, when was the universe created? It was 13.8 billion years ago. Earth was created around 4.54 billion years ago. Modern human beings are there since 300,000 years ago. Civilization started from 12,000 years ago, and written records are available since last 5,000 years. And since that, we have not stopped. The growth has continued, especially on two areas. One is data and the other one is technology. Now the fundamental question, every teacher of the teacher who is teaching you databases or talking to you related to data, he will ask you, or or she will ask you the fundamental question, what do you mean by data? right? And you'll say that anything, number, figure, and all those things which you store is data. You can still further simplify it, saying that anything which you feel is relevant and you want to record it for future use is data. It can be anything. If I take you to say 5000 years back, people used to record their events on rocks. Whatever they used to learn, they used to discover, they used to record it on rocks. Then they started recording it on barks, then paper, then now digital, right? But then still till that time it was all manageable, but then it has grown exponential because of internet and social media, and for which you, me, everybody who is there in the session, who is not there in the session, everybody is responsible. Every click you make, every hashtag, every comment is adding to the data, right? Coming to the growth of technology, why technology here? Because technology is also responsible for generating data. So that's the reason technology, I'm talking about technology. Now, technological growth started from industrial revolution. We all know, we all have studied it in our school, right? And we are looking at it again and again. Now, if you remember, if you recall, your first industrial revolution to second industrial revolution, 100 years. Second to third, almost 100 years, little less. Third to fourth, 60 years, 55 to 60 years. And now, every day you're coming out with new technology. You name it: Internet of Things, augmented reality, virtual reality, blockchain, AI, 3D printing, drones, robots, whatnot. And I I want to say best part of it, but I don't want to say that. And these technologies are coming together to give birth to the third technologies. So, and eventually all of this together, they're contributing towards the addition of the data which is there, which is getting added to the list of exabytes, zettabytes, and whatnot, right? Now, do you think this is new? I mean, we have seen three paradigms of science, and we say that data science is the fourth paradigm, right? Starting from empirical science, then theoretical science, then computational science, and now it's data science, right? So is it that new? I mean, we all are talking about it. We all want to try our hands on it. In fact, it is, I mean, nobody is untouched. Whether you call yourself into data science or not, you are not untouched with this, because you do some of the other thing with data, in your day-to-day work. I say even children are into data science, even housewives are into data science, because they keep on looking at data and try to find out some meaning of maybe whatever data, little data they have. So I'm just trying to share that it is not something which is very new. So on your screen, I'm just giving you the literature which was written by R.A. Fisher in 1935, almost a century back. Then about quality. Quality is again not a new phenomenon, Deming had written about quality control in 1939 itself, Business intelligence was spoken in 1958. Exploratory data analysis, which is integral part of data science journey, was already there was already a book in 1977 by Turkey. Then business intelligence, because business was important, there was another book on this in 1989 by Howard Dresner, right? A very important book. 1997 there was a book on machine learning by Tom Michel, and till date this is one of the best book in machine learning, right? 1996 Google had come, and this was, I'm sure most of you must be knowing, this was the outcome of the research work, PhD work of Larry Page and Sergey Brin, right? 2007, see, we started feeling the heat of the data science, no? So fourth paradigm, which is data science, was there on the forefront in 2007 itself. Then Unreasonable Effectiveness of Data, the book was written by Peter Norvig in 2009, and he was trying to tell that instead of using complex algorithm, why not use simple algorithm? They also give you equally good results with the large volume of data. And by 2010, we were sure that there is a data deluge. There's a lot of data, and we have to have some mechanism to handle that. 2010 is 10 was very crucial time. I'll come on that a little later. 2010. So this chronology tells that it's not new, right? We have been, since the time we are looking at the data, we want to make sense of it. We want to use it for making decision, our day-to-day decisions, critical decisions also, right? We try to find out some patterns. So since the time we are looking at the data, we are trying to do all these things. But then why is the confusion? First confusion, there are two main reasons of the confusion. First confusion is because of the constant evolution of data science industry itself. And we will not go that far. Just 30 to 25 years back, there used to be statistician in every company. Now, what was the job of statistician? The statistician used to gather and clean the data and apply statistical method. But with time, we all know the data also grew, and also the technology improved a lot, right? So the same person who was known as a statistician, he started extracting patterns from the data. Now, after some time, there was a position called data mining specialist, right? Around 20, 25 years back. What he was responsible for? He was also responsible for gathering and cleaning the data, applying statistical method. And as I told you, data continuously grew and technology continuously improved, right? So he was also extracting the patterns, but he started developing new models, right? And the reason was to find out some accurate forecast, right? Then around 10, 15 years back, we had predictive analytics specialist, and his job was gathering and cleaning data, applying statistical method, extracting patterns, and performing accurate forecast, prediction, all those things, right? Now we have data scientist. What he does, everything what statistician used to do, everything what data mining specialist used to do, everything what predictive analytics specialist used to do, right? So the fundamentals have not changed. Statistics is the fundamental building block of your journey of being data scientist, right? Of course, you added multiple layers on it to make it more accurate, to make it more efficient, to make it more perfect, right? But then the fundamental is still there and will remain to be there. You cannot change that. And second confusion was because of HR managers. So the advertisement they made and the interview they conducted, there was a gap between that. The advertisement was about data analytics specialist and the interview was about data analyst, right? So there was basically the gap in understandings between in the subtle differences between the positions. So this led to a lot of confusion between the positions, right? So first confusion is about is regarding the evolution of the business, data science business itself, and second was HR managers, right? Why do we need data science at all? And the answer lies in something which I just told you, is like revolution of technology. So because of the technology, the most of the data started getting generated because of the revolution of technology. So there was a lot of flow of data. Most of the data was unstructured. Now, fortunately, now we have sufficient data storage. But I am taking you back to 2010 again, where we were not that efficient in data storage. We were struggling. We were generating the data, but we were struggling to store the data. Thanks to this distributed structure, like Hadoop and Spark kind of structure, which allowed us to store the data on cloud, allowed us to store the data in distributed manner and still made it available on click of it, right? So because of that, probably now we are in the best stage. You have data, you have technology, you have algorithm, everything is there. It is only that you have to be skilled to make sense of it. But I'm taking you again back because the story has to be continuous. So you had data flow. Most of the data was unstructured. We were blessed to be with this structure, storage structure, which allowed us to store the volume of the data which we were creating. But what we lacked was the capability to do predictive analytics. We lacked the data to make out the scientific insights from the data what we had. The moment we started using the data which was there available to you, was there at our disposal for decision making, for prediction, and for pattern recovery, we were in the realm of data science, right? So unless until you make sense out of the data, you can't say that, okay, you have lots of data, but data science field allows you, leverages you, gives you the skills to find out the meaning of the data, which you can use for decision making, to do some predictions, to find out some patterns, and then act accordingly, right? Now, same thing which I just shared on the previous screen, I'm just trying to show you the different version of the same story, right? So earlier we used to have all structured data. No one will deny that. We had databases and all stuff like that. Now, small databases has to be brought together, right? Because if suppose you're dealing with the database of a bank, right? So each branch will have their own databases, but the bank at the center will also need the data from all across the branches to make some decision at the bank level, right? At the central level, right? So all those smaller structured data used to brought into the data warehouse, which was again a structured place, where we used to store the data, right? And we had a few traditional BI tools which we used to use to find out some predetermined reports, right? What was the best selling product? Who was the best salesman? Which season, which product did well? So all those predetermined questions were very well answered through this system. But now, along with the structured data, you have unstructured data. In fact, more of that. We have storage like Hadoop and Spark with us, which allows us to store our data in a distributed manner. We have beautiful algorithms to handle supervised data and unsupervised data, right? And when you use these algorithms, you get the insight which can be applied to your business, which can be applied to the governance, to have effective results out of it. So we are in, as I told you, we are in the best time where we have all the raw materials available, tools, techniques available. It's just that we need to skill ourselves. Very fundamental thing, how we get into this, what is the general practice? I'm just trying to make it very simple and show it to you. So if suppose you set up a business, right? This gentleman has got lots of money and he wants to start a business. He has set up a business already, right? So the business will generate lots of wealth and also intangible wealth, which is data. Now he understands the wealth, right? But he does not understand the other intangible wealth, which is getting generated and then along with the growth of the business, right? But he is interested. He understands that something is getting generated, right? He wants to know what is this. So he will employ a data team. So data team will look into the data. They will try to rectify, okay, whatever mistakes are there in your data sets. Very very simple example is there on the screen, just to say that, just to tell you that data has to be correct before you start doing anything. Data has to be processed, has to be corrected. You cannot just take the data and start working on it. So data team will do all data processing and all. They will create a dashboard which will help you understand the distribution of the data, your spread of the data, your behavior of the data, right? So when you look at the table, or maybe for example, if you look at the Excel sheet full of data, values, you can't make out anything. The moment you convert it into a dashboard like this BI dashboard, you call it business intelligence, you call it descriptive data analysis, you call it data analysis. There are multiple terms for this particular stage. Do not get confused. You are essentially doing simple statistics here, right? So this gives you a complete idea of what is there in your database and how it is distributed, right? So basically data analysis. Now there are two terms, data analysis and data analytics. And there's huge difference. People keep on using these terms. in a wrong manner, without understanding. So when you look at the data, historical data, and try to make some graphs and charts to just make everybody understand, okay, this is the data. Okay, so 70% of the data is female and 30% is male, or 70% is literate and 30% is illiterate, kind of, kind of these kind of information, if they come up with the historical data, that is called data analysis. You are looking at the data and presenting exactly what data has to tell you, but it will not answer your how you have reached to this state and why have you reached to this state. For that, you have to have a data science team who will apply few data science algorithms depending on the type of the data, and then help you look into the peep into the future, right? Will help you make some forecasting, will help you make some predictions, will help you find out some clusters, find out some associations, right? Some correlations, all those things. So analysis is when you look at the past data, analytics is when you use the same data understanding to peep into the future, right? I'm going to talk on this a little more so that things are pretty clear to you, right? Let's get into some fundamental concepts. So data science, of course, data is the integral part of the this ecosystem, and data science, of course, algorithms will be used, right? So two types of data essentially you will have: traditional data and big data. So big data has got minimum 3 V's as to identify if the data is big data or not, right? So the first thing which you need to get into data science realm is the data, whether it is traditional data or big data, right? So at the beginning of your analysis, you will have this. Now, then you will have, then you come into the data science application part, right? So once your data is ready, you will try to apply some data science algorithm to find out some meaning of this. So there are various tools like statistical tools, mathematical tools, programming tools, problem solving tools, and data management tools, right? Essentially can be broadly categorized into these 3 categories. So business intelligence, I'm just repeating myself. You can call it statistics, simple statistics. You can call it exploratory data analysis. You can call it descriptive data analysis. You can call it analysis, business intelligence, whatever name you give to this stage of your data science. It is essentially making use of simple statistics to understand your data, right? So after your data is gathered, you will try to analyze the data which you have acquired. So helps you look into the historical data. Now, once you have fair understanding on your historical data, you will try to use your learnings to peep into the future, either through traditional method or through machine learning method. But both of them, purpose is same. You are trying to look into the future, right? Both have got the same goal. Now, the question in your mind must be when to use traditional method, when to use machine learning. I can give you a simple answer that when you have a traditional data, when you have limited data which can be handled by traditional method, go for it. If you have big data, go for machine learning, right? Now let me tell you the ecosystem. So all those things which I've just shared with you will come into this ecosystem, right? Are you all there? Just one confirmation, please. Am I audible? My screen is visible.
Yes, ma'am, your screen is visible and you're very audible.
So let's assume that this is the world of data science. This sphere, a circle on your screen, is the world of data science, right? So what all you will do in the world of data science? First thing, you need to have a problem, right? Now to understand the problem is very, very critical as a first step, because unless until your problem is clearly defined, you will not be able to do the right thing. So do not be hesitant in asking multiple questions. Do not be shy of asking questions. So ask multiple questions. Doesn't matter what the other person is thinking. how many people you have to talk to. Do not be hesitant, because unless until your problem statement is clearly defined, you will not be able to do justice with the entire cycle, right? So this is what we are going to look at, the life cycle of the data science. So problem statement is ready. Once your problem statement is ready, what you will need is the appropriate data. Now you do not know where you will get the exact data, or nobody will tell you, okay, you go and search at the corner of the road and you will find the data. Nobody will tell you. You have to search everywhere, every possible place where you think data can be available. It can be web servers, logs, databases, APIs, social media, online repositories. Go and hunt for the right data everywhere. This is again, I at every stage I'll say this, so please bear with me that these step is important. So again, this step is important, because unless until you have the data, you can't do anything. Now once you acquire the data, it is very essential that you prepare the data for next step, right? Now preparing the data, that when you pick up the data, you will feel that, okay, there are multiple columns which has got less than 50% of data. What are you going to, you can't even impute that, right? So better to drop that. You will find that multiple data columns are repeated, maybe with different names. And the students who have worked with me in couple of projects, they know this, what I'm talking about, right? So same data point, but with different name, you have multiple columns. So better to drop those extra columns, redundant columns, right? You will find that the same data value has been explained with the different wordings, right? For example, EDA. Let me give you an example of EDA. So somebody will write exploratory data analysis, somebody will write ED, somebody will write EDA. Okay, so essentially everybody wants to say the same thing, but different wordings have been taken. So different, it creates different data values, So you have to correct those also. You have to make it uniform. If there are spelling mistakes, those have to be corrected. If there are missing values, those have to be corrected. In case there is any transformation needed, you have to do that also. Like when we were handling our COVID data, right? We realized that that we need to have some instance, death instance or occurrence instance. So we calculated instance and added into our database. So those kind of addition if you want, transformation if you want, and those instances were calculated on the basis of data point, one of the columns only, right? So this comes under transformation. Or I can give you another example where, if suppose timestamp is stored in your database and you just want the year part of it, so you have to transform the timestamp to year part of it, take out the year part of it and use it. So all those kind of transformation as per your problem statement or problem definition can be done. Now once your data is ready, you have to explore it. Data is not saying anything to you, you have to explore it, right? Now you will feel, a thought will come to your mind that, okay, I have taken so much of effort, lots of effort goes in data preparation, right? People say, the study says that 80% of your time goes in data preparation. Now after investing 80% of time, you will get the sense of fatigue and you'll say, okay, now my data is ready, let me go and build the model. No, do not do that. You have to understand what data is trying to tell you, what hints you are getting from the data. Because if you skip this step, exploratory data analysis step, you might miss the important feature, right? Which is very, very important for building the model, right? So I would suggest this is important. Again, this is an important step and you should not miss it. Once your exploratory data analysis is done, you go ahead and build the model. Now, when you build the model, I mean, depending on the type of data, you may have supervised data, you may not have supervised data. So data essentially can be supervised and unsupervised. So depending on the data, there are many algorithms which are already there. Now, I cannot tell you upfront that, okay, this is the problem statement, go ahead and apply KNN. I will not be able to tell you that, right? So you have to apply all the models. So suppose you are doing prediction. So you have to apply all the models which are meant for, or most of the relevant models which are meant for prediction, and see which model is behaving in the efficient manner in your case. And case to case, this will keep on differing, right? So to build the model, There is a simple process. You divide your data set into two parts. One is your training part and the other one is your test part. So training part will be used to build a model, right? And test part will be used to test whether the model is behaving in the expected manner or not, right? Then you evaluate and then finally your model is done. Now, once the model is done, you cannot hold on to it, right? You have to share the results, share the outcomes with the agency or with the business or the customer for whom you have done this, you have solved this problem, right? And still the story is not over. You have to deploy in the real time scenario and keep on monitoring it to see if the model is behaving in the manner it is expected to behave, right? So this is the life cycle of data science. Now come back to the sphere. So this is, I told you, this is the sphere of data science, the world of data science. It will have data analysis, it will have data analytics. Now data analytics can also be called as data mining. And then one of the case, specialized case of text mining I have considered, right? So how will you start this process? As I have told you, by now you must be knowing that you have to start getting the problem statement, understanding the problem statement. Once you have understood the problem statement, you will start gathering the data, right? From all the sources, right? Now, once you have got the data, you will prepare it in a manner uh, so that you can start working on it. So data preparation is also done. Then you move to data analysis stage. Same data which has been prepared will be used to find out some behavior and distribution of the data, to find out some initial trends, right, and patterns. So all those things. Now this same data set, you have now fair understanding on your historical data, what your data is storing. You have now fair understanding. Now you will use the same data to look into the future, right? There are two ways, as I've told you: contemporary way and the modern way, that is machine learning way. So contemporary way is like you will use advanced statistics like regression, clustering, time series, so on and so forth. And the modern way is like using machine learning, which is a part of artificial intelligence. So what is artificial intelligence? When you try to make machine behave in the way we are behaving, the way we see, the way we speak, the way we hear and comprehend, the way we reason out, all those traits which are unique with human being, when we try these traits to be there in the machine, we are trying to build a artificial intelligence environment. So one of the popular thing which we have achieved successfully so far is machine learning, right? Where we train machine to learn on its own, right? There are so many machine learning algorithms. One of the algorithm is neural network, right? Where again, this is motivated by human beings. So the way our neural system functions, we receive some input, we process it, we add our experience to it, and then we decide whatever we have to take a decision on. The same concept has been used in neural network also. Now this processing part, which I told you, input, process and output, when you do this processing part multiple times, it is nothing but your deep learning, right? So coming to data analytics, which can also be called as data mining, you have two ways to proceed. One is advanced statistics and other one is machine learning. Now coming to text mining, which is still a specialized case of data analytics, because most of the unstructured data which we are creating or generating is in the form of text. It can be a book, it can be an email, it can be a tweet, so on and so forth. It can be comment, social media comment, so on and so forth, right? Now, how this unstructured text which we are generating so profusely will get treated by machine learning algorithm. So here sits another concept, another technology, which is known as natural language processing, which converts your unstructured text into a form where machine learning can further take on and process, right? Now, once you have done all of this, you will like to have visualization to express your story, to share your story with the world. Now, look at the screen, I have told you that this sphere is data science. Of course, I could not find any smart art to design it in this way. So this entire thing on your screen is the world of data science, and everything which you talk about, which we have spoken about, is a part of this. Data is part of data science ecosystem. Your data analysis methodology is part of data science ecosystem. Data analytics is part of this. Test analytics is part of this. I have heard people talking about like, okay, Python is data science or R is data science. These are the tools which will help you in the journey of data science, right? Machine learning is an algorithm which helps you in the journey of data science, right? So everything which you see on the screen is part of the ecosystem of data science, which we call data science, right? I'm sure things might be pretty clear to you by now, and we can now define it, right? So data science, now I have taken this common uh, picture which is available on internet, to define it instead of defining it in a textual. So data science is a stream which allows you to extract data, process data, analyze data, perform some analytics on the data, and get some insight. Now, two things which are not there on your screen is identify the location of raw data, which is again a part of data science stream. Identify location, then only you will be able to fetch the raw data. And then the other part is when you get the insight, right? When you get a very good insight, you want to convert it into data product, right? So you can say that data science is a journey from raw data to be converted to as data product, right? And rest everything is a part of the journey, is a friend in the journey, as a helper in the journey. Now, where does this data come from? Rituja, how much time do we have? Can I extend it for maybe another 10-15 minutes?
Yes, I'm sure we can extend it.
Yeah. So just very quickly, from where does this data come from? You should be knowing, because if you want to work on the data, you should be knowing from where all the data comes from. So most of the data in the world of data science is big data. 80% of it is unstructured data, right? And other types of data is like semi-structured, structured. So difference between structured and unstructured is, I mean, of course, for any organization, 20% is structured and 80% is unstructured. That is what I have told you, right? Structure will have a structure, data type, all those things very formatted, whereas unstructured will not have any structure, right? It will be either image, audio, video, so on and so forth, right? It is easier to manage structured data. It is easier to manage the legacy system in the structured data, whereas it is very, very difficult to manage the unstructured data, right? Very difficult. So sources, the first set of sources which I am presenting to you is because of the evolution of technology. Phone, which was used only to dial the number, earlier, we used to keep phone only for one purpose, that you can connect and call and talk to somebody you want to, your family members, your relatives, your friends, and so on and so forth. But now you have mobile, which does many things beyond just making a call, right? Earlier we had a desktop which was limited in space, limited in storage, limited in memory. Now there's no limit. With everything on cloud, there's no limit. You can keep on extending it. So you need not worry about, okay, I have generated so much of data. You have space to store all those data. Car, which was known as the mechanical marvel, now it's a multidisciplinary product with mechanical engineering specialization, with electrical engineering specialization, with IT, computer science, AI, everything embedded. Now it's a smart car. It is aware of itself, what it is doing. Second data source, and which is again volume, it creates lots of volume, is IoT. It's a small device, it comes with sensors, actuators, and networking capabilities, right? So this again keeps on, every device we are getting these days are fitted with IoT, right? So it is self-aware, it is capable of communicating with you, and in turn generating lots of data. Social media, we all know, we all are party to it. And other all contemporary systems, your banking, retail, manufacturing, all of them have gone digital and generating more data, right? And the final category which I would like to share with all of you is open data. Uh, Now, this is a category of data which is basically provided to us by government, local government or central government, or by some business houses. They keep their data in open platform so that everybody can use it for research and try to find out more sense of it, right? Because it is generating, see, otherwise people never used to share their data. We have seen those days where people were reluctant to share their data. Now this is growing in such a volume that you want everybody to look into the data and make sense of it, especially to the researcher community, students community, right? So this is a very important source of data which I thought I must share it with you. Now, why it is so exciting, why data science is so exciting? To me, anything is exciting when it provides you good job, good salary, and good work to do, right? So I'm not saying this. This is by PwC. It says that 60% of job openings are analytic enabled, and it's not that it is there are ample job for you. The jobs are with good salary package also. So that is first attraction which makes it more exciting. And the second one is every domain has got the requirement. You can't say that, okay, you have this skill, now you are applicable only to this domain. You have the skill and you are applicable to everywhere. I say that data people or people with data science capability are like O positive, can contribute anywhere, can can be used by anyone, can save anybody's life, anybody's business, right? So be it travel, marketing, healthcare, sales. I mean, these are just few. This is very old picture which is available online, but then it has grown further, right? I would very quickly like to share a couple of examples, real-time examples with you where data science have been used, right? Google flu trend, right? Now, what Google has to do with flu trend? Identifying and notifying about the flu trend is a job of CDC, Center for Disease Control. Every country has it. What Google is doing here? Now, this is a web service, Google's web service, which has taken upon himself to identify the flu trend. Now, how it does it? It aggregates all the queries which comes to it related to a particular flu, right? And then tries to identify it. Now, this is one of the initial example of data science and very, very effective. If you want to read more on it, it is available online, right? So Google entering into healthcare, identifying or entering into CDC's shoes and trying to identify. And the frequency with which Google was presenting it was higher than what CDC used to do. If suppose CDC used to present or update their database, maybe once in a 15 days, they used to do every 4 days or every 3 days, right? So it was very effective, very accurate. Recommendation system we all know, right? It's a typical example of data science, where data science, you try to log into Amazon, try to choose a pair of shoes, couple of pair of shoes, come out without making a purchase. Now, next day, when you log into YouTube, you will see that those pair of shoes are following you. You ignore them, go to Facebook, you will still find those 4 pair of shoes following you. That means you need not go to the shop, they follow you. They assume that, okay, these are the shoes where a person is interested in and might turn into a perfect purchase. So they keep on reminding you, okay, you had selected it. Only after few attempts they try to then they stop it, right? So how this recommendation system work? They actually take your demographic data, which tells about your name, gender, your age, all those things. Then they look at your purchasing pattern, right? Then they look at your browsing pattern and they combine all of this and they recommend something which I'm sure you will accept that it is very close to what you would have selected, right? It is so close to your personal choice. Sports analytics, we are using it profusely. Data science has been used profusely not only to improve your own game, but also to plan on the strategies to win the game. Your own Amazon Alexa, it's your personal voice assistant, convert speech into machine learning, machine language, and then do whatever commands have been given to you. Very beautiful example of data science. Spam filtering, every day, every moment, real time it is happening. Uber is another example of data science and data product. Now, every morning when you try to book a cab, Uber or any cab, right? You will find every morning or evening when the traffic is more, when people have to go to their offices, when kids have to go to their schools and all those stuff, right? In the morning when you try to book your cab, you will find that the tariff is very high. How does it happen? Somebody at the back end does it to make more money? No, absolutely not. There's an algorithm called surge pricing algorithm, which is a data product, which, I mean, there's an algorithm which is working beneath, So the moment this demand supply equation changes for each cell, this particular company works on the cell basis. Your geographical area is divided into multiple cells. So as the demand supply grows in particular cell, the help from the other cells come to this particular cell, so that um, the person who wants to travel gets a travel, and the driver who is basically sitting idle gets a job. Now, since he has to travel from other location to your location, he has to be incentivized, right? So that's the reason there's a surge pricing, right? And beautiful example. And Uber has got multiple data science product being used. Logistics, we are using it day in and day night. Your smart car, autonomous vehicle is an example of data science. Smart watches, and believe me, they have saved life, because of the continuous reading. And the moment they look in the they look at some disturbance in the readings, they notify immediately, and then many lives have been saved because of this. Facebook tagging, the moment you upload your photographs, it will ask for tagging it, and most of the suggestions are correct, right? Not only all these things, but also for election we are using data science. The historic was Barack Obama's win in 1912 was because of the team of data scientists. Page ranking is another example of data science. So I mean, these are few recent ones which I thought I must share it with you. Now, if you decide to enter into this field, what skill set you should possess? Of course, as I told you, statistics, knowledge of statistics is must. You should be knowing programming language, R, Python, or some more languages, which may help you in understanding. Data extraction and processing skill set should be there. Data wrangling and exploration, you should be able to do it. You should be having a good sense of machine learning. Big data processing framework knowledge should be there. Data visualization. Now you will say that one person cannot be good at everything. So depending on what you are good at, different positions have been carved out. Now, apart from the skill set which are there on your screen, there are two more important things which you should possess. One is the domain knowledge. The domain knowledge of the domain in which you are intending to work, right? You should have a good domain knowledge to understand what data is telling you, right? And second one is your communication skills. So communication skills is like universally required. You have to possess a good communication skills, and that does not happen overnight. You have to practice it, rehearse, practice, keep on improving yourself. Okay, now let's look at some job roles. Now, these are just few popular ones, right? Data scientist, data analyst, data architect, data engineer, statistician, database administrator, business analyst, data and analytics manager. So, I mean, couple of them are overlapping. I mean, you just have different name, but when you look at the task wise, it's kind of overlapping. So let me start with database administrator. Now, this was the role when we used to have a centralized Oracle database or some database like, right? So there you need to assign, you cannot give access to all the people in the organization to the entire database. So you want to have a specialized view of the database to particular lot of people. So to assign those users, to see whether your database performance is good, all recovery logs, all those things were looked at by database administrators, right? Now, data analyst and business analyst are more or less same, doing same thing, right? Then data architect and data engineers are more or less quite many overlapping tasks they have. Data scientist and data managers kind of overlapping task, and statistician like pure statistician, right? So out of all these and many more, which I could not put on the screen, and you will find marketing analyst, that is a position. You will find such positions, you know, depending on the company you are working, you will find some position. But fundamentals are these three, which I'll just share with you. Let me not start with data scientist. Let me start with data engineer. Now, why I told you the entire story, entire ecosystem. So first job is to see that your data comes to your premise, you know, in your custody. So who does it? Who decides that this is the way data has to be stored, right? So you have specialists like data engineers or data architects. So data architects design the way data will be retrieved, processed, and consumed, whereas data engineers processes the obtained data so that it is ready for analysis. So basically, data engineers will create a data pipeline for the entire data which has been created, and they will start focusing on coding, cleaning up the data set, implementing the request that comes from data scientists, so on and so forth, right? So first job is, that's the reason I changed the sequence. So first job is to get the data in your premise and custody, right? So who takes care of efficiently doing this? Data engineers and data architects. So they design the way data will be stored in your organization, how the data will be accessed, processed, right? Then, oh, sorry, let me tell you about the salary package also. And this is global. So as a data engineer, you can earn around 1 lakh USD as an average salary. The skills which are needed to become data engineers are programming, mathematics, big data, knowledge of big data, and so on and so forth. Tools you must know, like Hadoop, NoSQL, Python, so on and so forth. More the merrier, right? Now, coming to data analyst, once you have the data, you would like to see what is there, you know. So you have these people called data analyst, very important people called business analyst. They will look into this data and try to give you some insights about it. Their salary package is around 65,000 USD, and the skill set which is needed to become a data analyst is statistics, communication, business knowledge, so on and so forth. Then the tools which are needed to be known to these set of people are Excel, Tableau. These are all SQL. These are all like Tableau is like data visualization tool. Excel is like, again, you can do a bit of data visualization using that also. SQL you will use to fetch the data, present whatever you want to present, right? Now comes your data scientist, which is also known as statistician, which is also known as data managers, right? So these are the people who will take data science project from end to end, right? From beginning to end. And they will also use the traditional method as well as machine learning methods. You know, whatever is needed to find out the answer, they should be capable of doing everything. They will actually create some models. They will tell the stories about their findings. So these are the people who will actually crunch the data, right? Now you have furthermore specialization like ML manager, ML specialist, AI specialist, all those things are there. Those are carved out of this only, right? Salary is around 1,15,000. As per LinkedIn is a 1,15,000. As per Glassdoor, it is 1,16,000. What do you need to know? Mathematics, programming, communication, tools you should know is SQL, Python, R, right? So just to summarize, data scientist, I mean, as per Josh, data scientist is someone who knows more statistics than computer scientists and more computer science than a statistician. So essentially, data scientists should be good at both, right? Another definition by Shlomo says that data scientist is a combination of statistics, programmer, coach, storyteller, artist, right? So, I mean, very versatile person. So, just to summarize the skill set which is needed: programming and database, communication and visualization, domain, and of course, your maths and statistics, which are fundamental. So if I mean, see, if you know a bit of software engineering, math, stats, you can go for data engineering. If you know data, if your data communication and math, stats are good, you can become data analyst. If you have software engineering and data communications, bit of statistics also, then you become. I mean, you should to become data scientist, you should have all these three, right? So you can start your journey as an executive who has got affinity about data, affinity about looking into the report, making sense out of. You can start your journey as a executive, move ahead to analyst, business analyst, where you do some analysis work. You can become data architect, who can design your data warehouse, data lake, so on and so forth. And then you can become your data scientist. So this is what is the ladder which is usually formed in the organizations. Depending on your journey, you can be at one of these ladders, right? So I would also like to introduce you to a couple of famous data, I mean, these positions. I have introduced you to three positions. So famous personalities in these three positions. So DJ Patil is a first chief data scientist who was appointed at USA White House. And after that, the position of data scientist became kind of fashion in all the companies, you know. Doug Cutting is a data engineer, the creator of Hadoop, and a member of Apache's board of directors. Is a model of the data engineer who builds tool for processing big data. Then you have Roger, and he is basically a data analyst, and he has a good stint at a pharmaceutical company. So these, I mean, these are few famous people in their respective roles, you know. Couple of facts which I just want to share with you. So as per LinkedIn, data science is the fastest growing role, and it is going to add around 11.5 million jobs by 2026. So since 2019, it has been observed that 46% growth in this data science hiring. And in spite of COVID and all, in India alone, we had 93,000 opening in data science, right? So undeniably, there is lots of requirement, you know. Now, as per the Bureau of Labor Statistics, around 36% growth rate has been observed. And when you look at different roles, which where the average growth is just 5%. So this again to validate that there's ample growth in this particular stream, because there is ample requirement, because there is surge of data, because there is requirement by every company, because there is so much to be looked into, and dearth of people. 95% of companies say that managing unstructured data is a challenge for them because companies are facing problem. McKinsey says that 47% of respondent, they say that because of data science, they have an edge over their competition. And Glassdoor says that 4.1 out of 5 score is given to data science job satisfaction. You know, the people who have chosen, they are satisfied with the job, because I think it's like a game. You know, you take a data, try to find out something, you get involved into. It's not a rut of the thing. You know, every new problem is a, it comes with a new excitement. You know, so maybe that could be the reason for the high job satisfaction. Again, presenting you the salary positions, minimum salary in particular. If you join as an intern, you will have 1.8 lakh annual package to 11.3 lakh annual package, and it keeps on growing. To me, salary should be the last consideration for you. If you are really passionate about anything, forget about data science, anything. It automatically comes if you have this skill. And I keep on telling this to the students, to whomsoever I meet. you know. uh, it will automate. It's a byproduct of your hard work, it's a byproduct of your skill. So need not focus on this. But what I want to share with you, it's growing consistently. You can, with your good skill set, you can earn a good salary here. And this is all in Indian context, it's not global. What on your slide, what you see is in Indian context, and everything is in lakh, right? These are few companies in India and the salaries. Like I'll just read out few, not the entire list. So Apple is the highest payer in this list. The range is from 10 lakh per annum to 75 lakhs per annum. The experience they need is 2 to 9 years of experience, and the qualification what they are looking for is bachelor's or master degree in science, or some equivalent experience with I mean working at data science as a data analyst, wranglers, and so on and so forth. So on this page, the salaries are on the higher side. I just want to highlight that the salaries are on this higher side. The next page, the salaries are, I mean, these are also very decent salary. You know, getting a 37 lakh package is not a small job, right? So Oracle, Bharti Airtel, Wells Fargo, Samsung, VMware. No, there are many companies. In fact, all companies. I come back to my same statement that every company needs one data person who can look into their data, right, with a good skill sets. Now coming to my journey, this is very very simple for me. It was a natural flow. When I was doing my masters, my natural inclination was towards databases. It was a core subject, so I started liking that subject. I did some specialized course in Oracle also. When I went into the company, it was on my database. My initial first company was Tata Refractors. So there also it was like my job was to work on Oracle. So again, data. Then when I moved to academia, again I taught databases in all the forms, you know, fundamental databases, distributed databases, parallel databases, what not, you know. So and then my PhD was in data mining. So that was, and then I mean I thought I should bring all people, you know, who are into data science, and do something good, because there's sky is the limit for this field. So then in 2018 I formed a specialized professional group, not for profit, by name Society for Data Science. And we are working together, and I'm very happy to share that the society is doing very well. Of course, because of our bandwidth, we cannot give more time to it, but then organically it is growing properly nationwide. Internationally, also, we have a couple of people who are associated with us. We are doing good work, and the reason for not scaling it up is also that we just want to grow that much we can handle. You know, so just growing and not being able to handle is very damaging. So we are doing that much we can handle. So this is what you know, my data journey. uh, I have given multiple talks on this area. I have been associated with one of the universities in Germany, where I conduct data science course every year. They call it data mining course every year. And while I was doing that, of course, most of my research papers are around this. A couple of books which I want to share with you is, this book is 2019 published, I think 2020 published, Open Data for Sustainable Community, where I just wanted, because of my craze to look at open data, along with couple of students from Pune section and couple of students from outside also, we did this project where we looked at the open data. First, there were three case studies. You know, this book is divided into three sections. So first one looked at tree census and air pollution, and this data comes from Pune section itself, I mean Pune city itself, you know. And uh, then we looked at agriculture as a problem. This is very interesting, because we don't have time, I'll not get into that. This data set we get from central government data.gov.in. And since we wrote this book when COVID was there, so of course looking at this demand supply of healthcare, human resource, and infrastructure was kind of mandatory, you know. So this data set was like a worldometer which was available to everybody, and so on and so forth, right? The second book for which we were awarded also, it's towards net zero target. And this book looks into four domains, right? One is banking and insurance. Second one is renewable energy, non-renewable energy. Then third is household, and fourth is transport. So we just try to look at all these domain through the lens of data science, and using the data which is available, how we can curb the carbon emission by these fields, the last one is bringing the view of corporate, of data and analytics world of business. So here we have all the associates of TCS who have contributed. This book has come out. So with that, I would like to stop. I hope this was useful. And as promised, my phone number and email ID is there on the screen. If you want, you can contact me. If you have any query, I can take it. Since it's already 1.5 hours, I think we must stop. I mean, I leave it to Rituja and team. Yeah. Thank you so much.
Thank you so much, ma'am, for providing us with such thoughtful information and for making the session so interesting. And we'll now move to our question and answer session. And I am happy to share that we had done a survey for the session, and students had actively participated and shared their questions regarding this field. But and happy to say that almost all the questions were answered in the session. So while we take up a few more questions, I also encourage all the viewers to put their queries and doubts in the chat box if they have any, despite such a great session. So,
Rituja, I'll request you to take one or two questions because we are already at 12:03.
yes,
And
yes, ma'am. Yes, there's
yeah.
actually one question that for freshers specifically, it is very difficult for students or for freshers to get into the field of data science. So, are there any online courses or certifications or boot camps that you would suggest for freshers or specifically for students that would help them to get into the data science?
Yes, yes. So basically, there are so many courses available. You can, and those are very, either most of them are free. I always ask the students to go for free courses, and if it is paid, it is like with nominal charges. Like Udemy has got beautiful courses. Simply Learn has got lots of courses. Then I mean, there are so many sites available with beautiful contents. You should actually complete a course, end-to-end course, to get a hands-on. And while you are still in college, you should do couple of project. Your target should be, if you actually want to get into this field, your objective should be to complete at least 3 to 4 projects while you are still in college. So and all those should be from 4 different domains. If you're targeting to do 4 projects, should be from 4 different domains. So doing projects in different areas will give you um, exposure to different types of data with different types of problems, and that will enhance your knowledge towards this particular field. So yes, so lots of free stuff are available. Please make use of those open free stuff which are available to learn. And problem statement, of course, I mean, you can reach out to any one of us. I think there's no dearth of problem statement. As a country, we have lots of problem to solve.
And also, how can one network with professionals in the data science community and attend relevant conferences or events?
uh, See, I mean, now this is what the answer which I'm going to give. It's not relevant only to data science. As a student, and this is to all the students and all the professionals who are there on this call, in this meeting. We should, if we are serious about our career, if we are serious about whatever we are doing, we have to be part of some or the other professional body. We have to see whatever we have learned, be it data science or no data science, how it is applied. So learning is effective only when you apply it. So I mean, IEEE is a best example right? So I'm sure most of the students who have joined are all IEEE members. Continue with that membership. Try to explore, is there any group which are working? So now once you are there in the IEEE group, you will get to know about more specialized group. You can be part of that. Like we as a professional members, we are part of multiple groups. Like we are part of TEMS group also within IEEE. We are part of education society also. We are part of engineering medicine also. So there are multiple, and most of us are part of multiple groups depending on our interest, right? So unless and until you enter into, now you will say, okay, there's a fees. Now fees is a kind of investment which you have to do. Without investment you cannot grow, right? So you have to take effort to be part of that network, and then network will start helping you out. It will not happen that you will be out of the network and expect some help from the network. You have to be in the network. Not only look at getting the help, you should look at also helping and contributing towards that network also, strength of the network also.
Yes, ma'am. So, with this, we come to an end of this session for data science. Thank you, ma'am, for sparing your valuable time today and delivering such an insightful session on career in data science. Big thank you to all our viewers as well for joining us today. Your active participation and enthusiasm made this event a great success. Thank you, everybody, and have
Thank
a
you.
wonderful weekend. Thank you,
Bye
ma'am.
bye. Take care.
Bye.